Hello friends, welcome to today's lecture Design of doubly reinforced section. So let us see design procedure for doubly reinforced beam. This is the cross section of the beam having width B and effective depth D with effective cover DC on the compression side. This is the XU. This is a stress distribution diagram for balance section. For balance section, T force will be 0.87 Fy AST1 and for that C force is 0.36 FCKB into XU. That C force only due to concrete above that neutral axis. Now this is the cross section of the beam containing AST2 and ASC, that is area of the steel in compression side. And this is the stress distribution diagram for this particular sketch. So C force and T force. Now T force is converted, that is 0.87 Fy into AST2 and C is equal to FSC into ASC. So let us see design steps. So given value for design of doubly reinforced section is width of the beam, depth of the beam, material, DC and MR. And find will be AST and ASC. First calculate MU limit. We know that MU limit depends upon grade of the steel. So for Fe250, MU limit value will be 0.149 FCK BD square. For Fe415, MU limit will be 0.138 FCK BD square. And for that Fe500, MU limit value will be 0.133 FCK BD square. To calculate AST1, for AST1, considering this MU limit value, calculate AST1. For using formula that AST1 is equal to 0.5 FCK upon Fy in bracket 1 minus square root of 1 minus 4.6 MU limit FCK BD square B into D. Or MU limit is equal to 0.87 Fy AST1 D minus 0.42 XU. And this XU will be balance section XU, that is XU max. By using formula, calculate AST1. Next, to calculate AST2. For calculation of AST2, we require find out unbalanced moment, that is MU1. How to calculate MU1? MU given minus MU limit. MU given minus MU limit. For AST2, MU1 is equal to 0.87 Fy AST2. This is a T force. And D minus DC, it is a lever arm, that is Z. So total AST is equal to AST1 plus AST2. To calculate ASC, similar manner, MU1 is equal to now C into Z, that is C is equal to now FSC into ASC D minus DC. This is the design procedure for doubly reinforced beam. Let us see one example. Design a RC beam for a flexure in size is limited to 300 by 300 mm. For ultimate moment 87 kN, use M20 and Fe415. And DC is equal to 40 mm. So first write down given B is equal to 300 mm, that overall depth is equal to 300 mm. So effective depth is equal to 300 mm minus 40, so is equal to 260 mm. FCK is equal to 20 Newton per mm square. Fy is equal to 415 Newton per mm square, and MR value is 87 into 10 raised to 6 Newton mm. So first calculate MU limit. For Fe415, MU limit is equal to 0.138 FCK BD square. So MU limit value is equal to 55.97 into 10 raised to 6 Newton mm. Now compare MU and MU limit. So MU limit is less than the given MU. So design doubly reinforced section. So first of all calculate AST1. So AST1, first we require to calculate XU max. XU max for balance section for Fe415 is 0.48 D. So XU max value will be 124.8 mm. So MU limit is equal to 0.87 Fy AST1 in bracket D minus 0.42 XU max. Put up all values and calculate AST1, and that AST1 value will be 746.78 mm square. Next, to calculate AST2. For AST2, we require to calculate unbalanced moment. That unbalanced moment is equal to MU given minus MU limit. MU given is 87 into 10 raised to 6 and MU limit will be 55.97 into 10 raised to 6. So unbalanced moment is 31.03 into 10 raised to 6 Newton mm. For AST2, mu1 is equal to 0.87 Fy into AST2. This is a T force, and D minus DC, it is a lever arm Z. So put up all values. Unknown term is AST2. So AST2 is equal to 390.65 mm square. Then calculate total AST. Total AST is equal to AST1 plus AST2. So total AST is equal to 1137.43 mm square. Then next, calculate ASC. For calculation of ASC, mu1 is equal to FSC into ASC in bracket D minus DC. Now first we require to calculate FSC. FSC depends upon DC by D ratio and grade of the steel. So first calculate DC by D ratio is equal to 0.153, say 0.15. From table, the DC by D ratio for 0.15 and Fe415, the FSC value will be 343 Newton per mm square. So put up all values in this equation. Unknown term is only ASC. So calculate ASC. ASC value will be 412.41 mm square. So this is a final solution for doubly reinforced beam. So dimension of the beam is 300 mm 300 is given. So AST value will be 4 bars of 20 mm 5 and ASC value is 3 bars of 16 mm 5. This is the design procedure for doubly reinforced beam. Thank you.